Lights go right. Lights go left. Lights go right. Lights go left. Lights go down. Lights go up. Lights go down. Lights go up. And when the lights are down, you can turn them even further. Because when they're pointed down, they have more clearance between themselves and the windshield. But when you tilt them back up, that clearance goes away. And even though I haven't turned the steering wheel, the lights move back to accommodate, so they're not crashing. They have the smarts to know that they're about to hit, and they don't do it. They go back. It's kind of neat. Feature I'm a little bit proud of, not gonna lie. So yeah, that's that. Lights that move and stuff. If you look from above, you'll see that they're a little bit cross-eyed. The reason why they're cross-eyed is they point, into the turns. If you have this one going left, its light will hit the side of the housing. And you don't want the light hitting the side of the housing. It doesn't go anywhere then. So if you want to illuminate a left-hand turn, you want the projector on the right to do that, because it has the whole wide open area for its light to travel, whereas this one would be obstructed, and same vice versa. This one, it has a better view into right-handers, so it's already tilted a little bit right, so that you're obstructing less of the light that it produces. So yeah, it's cross-eyed, and yeah, that's how it's meant to be, and we're about to see how that works. What you're witnessing here is the culmination of a project that was conceived about 5 years ago when I took this car on a road trip from my home in Michigan to California. Driving through the canyon roads around LA at night was, unfortunately, very effective in highlighting the deficiencies of my former, more conventional lighting setup. I didn't have the greatest grasp of where I was headed, and I was relying on the extensive and fortunately reliable local knowledge of a friend riding shotgun, rally co-driver style, feeding me nuggets of info on what light I had. The trip was an absolute blast, but I knew that my vision of an ideal road-going hoon machine needed more capable lighting. This lighting concept has existed in a couple of forms over the years. I'll go into more detail later in the video on how the system works, and show a montage of my fixing some things that still bugged me with the current version. For the remainder of this test drive, I'll share some of my design considerations. I wanted a solution that wouldn't compromise the car's daytime performance. That meant lightweight, no extra drag, and nothing that would obstruct airflow to the heat exchangers. This rules out extensive auxiliary lighting setups, anything tacked onto the exterior, and no tucking extra lights into the grille. Additionally, with the car being low, any light solution that was going to be mounted low on the body, or even in a conventional location, was going to be a compromise. That is because a low-mounted light has to be aimed almost parallel to the road to shine sufficiently far. A higher-mounted light can be aimed downward at a steeper angle while still shining the same distance. A light that shines down at a steeper angle is kinder to oncoming traffic than one that is nearly parallel with the road, because it'll have less propensity to point upward over bumps and undulations in the road, flashing oncoming drivers. The servo that allows me to control the pitch of the lights was added as a means of compensating for the effect that heavy items in the trunk have on the pitch of the car, again out of respect for oncoming traffic. As far as legality goes, Michigan requires that headlights be within 54 inches of the ground. Many other states require that they be within 48 inches. The car is low enough for these lights to be 50 state legal in terms of mounting height, despite being at the top of the windshield. All in all, these things seem to work really well, lighting on par with what you get in a lot of modern luxury cars, but that's just on streets around my hood. The real test will come in October, when I take this car to the Tail of the Dragon in North Carolina. For those that don't know, that's a ridiculously twisty road that's surrounded by excellent driving roads. It's a hot spot for car enthusiasts to go and play around. It'll be as good of a place as any to see how these lights really perform. I'll certainly be doing a video on that when the time comes, so if you're interested in seeing how the lights perform in that setting, please subscribe and sign up for notifications so that you can see the update when it arrives. Anyway, we're going to transition to the process of getting these lights fixed up after a period of neglect, so buckle up and smoke them if you got them. So here's what we've got to do. And the main thing that I need to do before this thing will be operational again is make a new enclosure for them. I had this big enclosure before, but you know, you heard that adjective, it's big and it's kind of in my line of sight and it makes it difficult to drive this thing. So I need to make something smaller. This is a fleeing Aaron, and this is a pile of wood that's going to become a mold. Here is my mold. It's basically the same thing as this original one here. It's just about 4 inches narrower, so it should obstruct my sight less. Since this is a quick and dirty one-time use mold, I'm not going to bother doing anything fancy to treat the surface. I'm just going to line it with foil tape. Once that's on there, I'll hit it with some wax, and then the parts that I make should come off easily enough. Is it the lunar lander? Or is it the mold for my headlight? Well, I guess the pan out was a giveaway. But in any case, it's done being wrapped in foil. I have to put some wax on it. Here it is. It's all set up. It said 24 hours to cure. Now it's ready for some cleanup and then to be removed from the mold. And at this point, I'm regretting just a little bit using so much glue in the mold. I think just screws would have been sufficient, and the glue made the thing a whole lot harder to disassemble. Got a template that I'm happy with. Now time to transfer it over to this guy. So next up, I've got to tackle the wiring here. It's not too difficult of an operation. There are 3 different servos, and also these are what you call bi-xenon projectors, and that they have a high beam that's activated by a solenoid. So the solenoid differentiates between the low beam and a high beam. So I've got to wire those two. The plan right now is for all of these to share a power and ground. However, the solenoids, they're going to need their own signal, and each of the 3 servos will also need their own signal. So for that purpose, I have this 3 conductor wire here. One of these will serve all 3 of the servo signals, and then I'll probably run a second strand of this, which will serve as the power and ground, as well as the signal for this. So all this nonsense here can be controlled by 2 of these wires. Alright, so we've gotten into the electronics part of the project. I have the car pretty much wired up, as you guys saw. Now time for the controls. This thing historically has been driven by an Arduino. It will still be driven by an Arduino. When I say historically, I mean that it had adaptive headlights that panned with the steering inputs. Now it does more. It has the capability to do more, at least. It can tilt as well. So the idea is to have this take the input from the steering angle sensor to translate it to panning in the headlights, and then there's gonna be a knob that allows me to adjust the tilt. So if I need the headlights higher or lower for whatever reason, I have a knob to accomplish that. So here we are, back in the car. I've got something to say. So dope, you'd think it was produced by Dre. No, just kidding. I made a little bit more progress on this thing. I have some wiring done. This guy here goes to this steering angle sensor potentiometer. Let's see, turn the wheel and the gears move. It's kind of neat. But that's how this control system for the headlights tracks the steering angle position. And also I have these trim potentiometers so that I can fine-tune the positioning. Other wiring accomplishments. This wire here, obviously I still have some organization to do, but it's coming along. Things are getting hooked up. These are the signal wires for the servos, the 3 servos that I have up here. Only have 1 wire left, really. That's this guy. The black one is a ground. Red is 12 volt power, and then the yellow one is, okay, no, I misspoke. Black is ground, red is 5 volt power. Don't want to mix those up. Those power the 5 volt servos. Yellow is 12 volts, and it's not a constant power supply, but rather it's the high beam trigger for the solenoids, and these here bi-xenon projectors. So I just have to hook the power up to this guy, this 5 volt voltage supply doohickey, and then this thing should work, once I do a little bit of programming in that Arduino. I have no idea what the last thing that was on there was. I think it just held the servos at constant position. Sometimes the wires don't come to you, you have to go to the wires, so... I'm gonna guess you're not here to watch me do yoga, but in the event that you are, I'm pleased to have not disappointed. And that guy can move too. But this third guy on the right, what's the deal? So these other ones here, when I try to move them, they fight me because, you know, these are servos. You send them a position. Their job is to maintain that position. This one's trying. If I move it, it goes right back. This guy won't budge. Super torquey, staying put. This thing, no fight in it whatsoever. So either the servo's fried, which I don't think is the case because this thing has functioned in the past. What I'm guessing happened is that the power just isn't being supplied to it properly. So I'll have to dig through some wiring, do a little bit of troubleshooting, and see if it's hooked up. But otherwise, whoa. So I have the servos all mounted up now. I got the wiring a little bit more orderly. I added these springs to add some preload to the system so that way, you know, as the car vibrates and so on at idle or as you drive around, this will bounce around a little bit less. It just kind of soaks up the lash in the system like a tensioner would. I just got finished with the programming here. It's just, you know, code that's on this Arduino. And I have these 3 knobs to adjust the positions of the servos. But essentially what this code does is it allows the knobs that I just showed you to control the positioning of the servos, and it also establishes limits so that you can't crash the projectors into the windshield or into other hard stops. For instance, you drive these too close towards each other, they'll crash. You drive this projector too far inward, in this direction, it'll just hit the windshield. So I have to have some smarts in the code to prevent that from happening. Otherwise, you can run the risk of burning out the servos. If they're trying to move the windshield, they're not going to succeed and they might die trying, and that's something I'd like to avoid. So I'll give a quick demonstration of how these limits work. I guess at first I'll show you the inner limits. As hard as I try to make this thing move towards the center, it stops there. That's all it can do. Same with this other side. The next limit is on the tilt, which is this servo right here. This is as high up as it can go. Basically, this actuator rod is at full extension, and turning it any more clockwise won't gain you any more upward movement. So that's as far up as you can go. And as you go down, there's a limit as well, and that's that as you tilt these things forward, they kind of go down some, and there's an enclosure that's going to go around this. And this lower limit is to prevent the projectors from crashing into the enclosure. Once that's installed, you can't see it, so it's not there for reference, but that's what it's for. Also a practical limit. You don't really want to lower your headlights this much anyway. The point is to see forward, not to just light up your head. So there's that consideration as well. Another limit that's kind of the most interesting of them is that the amount that you can turn these projectors inward to see into turns is dependent on the angle that the tilt mechanism is at. You see, when it's tilted all the way up, the projectors get kind of close to the windshield. When it's tilted down, you have more clearance. So what that means is that when it's all the way up, you can't turn the projectors in quite as far as you can when they're lower. And you want to be able to walk that limit, because if the projectors aren't turned up all the way, or the tilt isn't up all the way, you don't want to be restricting the movement more than you have to. So I'll go ahead and tilt both of these projectors inward as far as they can go. Both of them move now, and both are at the software limits to keep them from hitting the windshield. You can see they're close to the windshield, but they're not actually touching. I can bump it there and then it'll go into it, but then it kind of comes right back. But watch what happens as I move this projector, or the assembly down with the tilt, they turn in even further. The headlights right now are fully functional. They work just kind of like normal headlights. You turn them on and they put light forward. But one issue that I noticed has to do with the startup sequence, and that's that the servos get power before the Arduino is booted up, and that results in servos that are energized that don't have any input signal. And sometimes, not always, but sometimes they just kind of move around erratically, crashing into things until the Arduino finishes booting up, and then it takes control and sends them to an appropriate commanded position. What I need to do to address that is have some way so that the servos can't be energized until the Arduino is booted up. The way that I intend to accomplish that is to add a relay in the system so that once the Arduino starts up, it triggers this relay, and that relay then in turn will power the servos. So that way the servos shouldn't turn on until the Arduino is ready to go. One thing that was convenient is that I just happened to be at a micro center the other day because I was building a computer, and they happen to have servos that are controlled with a 5-volt signal, intended for Arduino kind of hobbyist applications. But it seems perfectly suited for the job. It's $4, and it just happened to be something that I found in the checkout aisle when I was waiting to go pay for my stuff. So I'm going to try wiring that in today. Here's a quick schematic that I drew up, probably about as clear as mud, but I'll do my best to explain it. So here's the power source from the car. Here's the chassis ground. As you know, vehicle voltage supply, usually 12 volts, and then the chassis is grounded. This is a voltage converter. This is what supplies 5-volt power to the headlight system, because the headlight system, it comprises an Arduino and these 3 servos, all of which run on 5 volts. You can't feed them 12 volts, you'll burn them up, you have to give them 5, so that's why this device exists in the system. You put 12 volts in, you get 5 volts out. So, of the 5 volts out, you have one line going to the Arduino, and you have another going to this relay thing here. The relay, what it does is it takes a low current input, something like what the Arduino would output from one of its digital or analog pins, just a low current 5-volt signal. And what that does is it turns a switch that allows the relay to energize a heavier load. And in this case, that happens to be the servos. So you have 5 volts coming from this voltage converter, coming down through here into the relay. This is the switch portion. So one way to picture that, you have a pin here, and then there's kind of like a arm that goes between the two of them. This goes to an electromagnet. So when the Arduino gives it a little bit of current, this becomes magnetic. It pulls this lever up here, and it closes the circuit so that a higher current 5-volt can go through here to the servos and power them. And the reason I'm doing this is because the servos, they were coming on before the Arduino was booted up. The way it'll work now is once the Arduino is booted up, it can send a signal to the relay here and command it to send voltage to the servos. So that's what happens. Hopefully that made sense. Here we are back in the car. Arduino, obviously. That's the relay thing that we discussed. And here's my ignition switch. So let's see what happens if I turn it on. Before I do that though, pay close attention to the startup sequence. First you'll see lights start flashing on the Arduino when I turn it on. That's kind of the thing booting up. And once it gets into the main body of the code that controls the servos, then it'll turn on the pin to power the servos. So I turned it on, there's a slight delay, then once the Arduino is ready to go, that thing started up. So the significance of that, now the servos aren't moving around without knowing where they're supposed to be. Hold on a second. Did I just say that when I turn on the ignition switch, the Arduino comes on and the servos get power? I believe I did, but that doesn't make any damn sense. They shouldn't be coming on without the headlights. So, made a quick change. Ignition on, nothing over here. Headlights on, action over here. Up next on the docket for this thing is the steering angle sensor. One feature of these headlights that they had initially but no longer have right now due to some issues, which I'll point out in a minute, is the capability to steer into your turns. So when you turn the steering wheel, there was a sensor here that would detect that movement, and it would translate it to the panning of the headlights to better illuminate your way as you corner. So the problem with it, however, is the potentiometer in here. It's busted. It's in really bad shape. I've taken the guard off, and I've noticed something that kind of confirms my theory of why this thing failed. As you spin it around, sometimes it moves easily, sometimes it gets really tight. Like here, we're kind of at a tight spot. And it's because as you rotate it, something in here isn't totally concentric. So the gear lash changes depending on the phase of the rotation. And when you get to a tight spot like this, that force that's causing things to jam up is putting a side load onto this potentiometer shaft. And I don't think they like that. I think it would rather have a continuous light pressure applied, or ideally no pressure at all. The hole is being enlarged here to allow for greater flexibility in the mounting of the potentiometer, thereby enabling more flexibility in controlling gear lash. I had the realization that if I try really hard to get things aligned nicely, maybe I won't have that concentricity issue that I had before, where depending on the angle of rotation, the lash and the gears would change, causing this thing to get loaded up. If I can keep it straight, then I can have the lash just a little bit loose, you know, loose enough where I'm not putting a lot of force sideways into the shaft, but tight enough where I'm not skipping teeth. That's kind of the sweet spot. That's what I'm going to aim for. The Loctite for the gears is set up now. It seems pretty solid. I don't think that that's going to come undone, at least not in the short term. So I think I'll put the guard back on to keep this wire out of the gears. I can stick the steering wheel back on. Alright, checking in again. I have the hardware all sorted out, I think. New potentiometers on here. The gears are on, they're solid. Put the chain guard back on. Steering wheel is back on. When I turn the steering wheel, the potentiometer spins, which is a good sign. And with that, I am going to conclude this video. While it was not an exhaustive how-to on how to recreate this exact setup, hopefully my going through and fixing the issues that I had with this existing setup that I already had in place will provide you with some insight that will help you recreate a better system, should you want to, learning from the mistakes that I already made. So, if you found this video helpful, I appreciate it if you please like and subscribe. Take some time to produce this content, and the feedback is appreciated. Thanks, guys.